Hello class, and welcome to section 8.2, which is about quadratic functions in vertex form. By the end of today's lesson, you will be able to identify and graph the characteristics of the quadratic function in its vertex format. The vertex form allows us to easily identify that vertex point and is the easiest method to graph a quadratic equation. The form says f of x is equal to a parentheses x minus h squared plus k, where a is not equal to 0. So again, that a not equal to 0 means that we have that squared exponent so that we don't just have a straight line. The vertex is going to be hk. So this h number is our x value, that horizontal shift. So it tells us how the graph moves left and right. The k value is the vertical shift. That tells us how the graph moves up and down. That's our y-coordinate of the vertex. The a value is responsible for a couple of different things. First, it tells us if the graph is wider or narrower than the parent function. Again, we went over that in the last lesson, but if it is wider, it's going to be that a value has an absolute value between 0 and 1. If it is narrower, that absolute a value is going to be greater than 1. It also is responsible for telling us whether the graph opens up or opens down, and that happens depending on if our a is positive or if our a is negative. So that's where that negative portion comes in with the a value. The last thing is that axis of symmetry, the middle line of that parabola, is going to occur at x is equal to h. So that's going to be that vertical line at whatever the x coordinate is. So the first thing we're going to do is just identify some of the pieces based on different equations. So we're going to just identify the vertex and that axis of symmetry. So looking at this first equation, f of x equals x squared plus 9. Picking out my vertex, you're going to notice that there's nothing in parentheses. So that tells you that that x coordinate for your vertex is going to stay at 0. So if there's nothing in parentheses, our x coordinate stays at 0, which is the coordinate for that parent function. But then I have plus 9, so that means my vertex has shifted up to 0, 9. My axis of symmetry then, which you can abbreviate as AOS, is then going to be x equals 0. It's that x coordinate value. If I jump down to the next one, I've got g of x is equal to x plus 2 squared minus 3. Notice there's a plus sign here. Remember, the original equation had a negative in the parentheses. So in order to turn it plus, that means we're subtracting a negative 2. So for my vertex, my x coordinate here is going to be negative 2, and then my y coordinate is going to be at negative 3. When I look at the axis of symmetry, that's simply pulling out my x coordinate. So I've got my axis of symmetry at x is equal to negative 2. This last one down here, I've got negative 2 parenthesis x minus 5 parenthesis squared plus 13. That vertex, we're going to go ahead and look in the parentheses for our x coordinate. It says minus 5, so that means I'm going to pull out the positive 5 as my x value, and then I've got a positive 13, so I have a vertex at 5, 13. My axis of symmetry then is going to be at that x coordinate of 5. Notice this a value has no effect on the vertex or the axis of symmetry. This is only responsible for if the graph gets wider or narrower and whether it flips up and down. It does not affect these two central points of our graph. Go ahead and identify the vertex and the axis of symmetry for this equation on your own. Pulling out my values, I get a vertex at 7, negative 6, which puts my axis of symmetry at 7. The next thing we're going to do is add on to these characteristics by talking about the vertex, the axis of symmetry. The direction of the graph means whether it opens up or down, and then it also wants us to compare the width to the width of the parent function. So we're comparing the two different widths. So we're going to start Same process here for picking out your vertex. You're going to look inside the parentheses here. So I'm going to say my vertex is at, since I have a positive, that means minus a negative. So my vertex is at -3, and my y-coordinate is at 11. Then again, that axis of symmetry is going to be coming from this x-coordinate. So I've got x is equal to -3. Then when it comes to the direction of the graph, that's when I switch gears to look at this value out front. Right now it's just a negative sign, which means that it's a -1. Since it is a 1 here, I would say it is the same width as x squared. If it's a number other than 1, we're going to have to pay attention to whether it's wider, between 0 and 1, or narrower, bigger than 1. Last thing I need to do is pay attention to the direction of the graph. Because it is a negative, that's where we're going to say that it opens down. Our graph has been flipped upside down, so the open part is facing the bottom. Go ahead and identify those 4 characteristics for this equation on your own. Pick out your vertex at -10, 12. Again, plus is minus a negative. The axis of symmetry then is going to be at our -10. This a value is positive, so we have opens up, and then it is bigger than 1, so our graph is getting narrower. The next thing we're going to do is use those characteristics to help us graph. So when you are graphing a function in vertex form, the first thing you're going to want to do is pick out the vertex. So in this case, my vertex is going to be at -5, 3. So I'm going to put my coordinates at 1, 2, 3, 4, 5, 1, 2, 3. So that's my vertex point. The next thing I want to do is pick out 2 more points that I can use. So what you're going to want to do, your vertex is at 5. Go to the next number smaller than that. So 4. If your vertex was at 10, you would go to 9. If your vertex was at -6, you would go to -7. So pick the point to the left of that, and you would plug that into the equation. So 4 minus 5 is -1. -1 squared is +1. +1 times -2 is -2. Plus 3 is going to give us a value at 1. So my next coordinate is 4, 1. I should graph that correctly. 4, 1. I just talked through plugging that in. It is totally fine. Just plug it into the calculator and get the answer. When you do that, it is critical that you have parentheses around this quantity right here. If you don't, the exponent will only be going to the 5, and that's not what we want. So you need to make sure that the values in parentheses stay in parentheses. Now I said you needed 2 points, so the next one I'm going to go to is 3. So again, plug in 3. 3 minus 5, -2 squared is 4, times -2 is -8, plus 3 gives us -5. So my next point is at 1, 2, 3, -1, 2, 3, 4, 5. Now, this is where the axis of symmetry becomes important. So our axis of symmetry is at x is equal to 5. What that means then, I'm going to put a dotted line going to represent that axis of symmetry. The reason this helps us now is we need the other half of the graph. So I'm going to go across that axis of symmetry and mirror the points. So my 4, 1 becomes a 6, 1. My 3, -5 becomes a 7, -5. And that's how we get the other half of the graph. Then, this usually is the tricky part for people. I see a lot of people who start graphing and their graphs look like that. It comes to a point. I'm not going to be super particular about your graphing. I know it is difficult to get used to drawing these parabolas, but one thing I will be very critical about is it should not come to a point and then switch. That would be an absolute value function. So what you need to do, what I recommend, start at one point, curve through, and then finish it out in the other direction, and you should have arrows on the end because that graph keeps going. So again, steps to graph: find the vertex, find 2 points to the left of the vertex, draw in your axis of symmetry, and then mirror across that axis of symmetry, drawing in as the final step that curve, making sure it does not come to a point and that it is actually curved. Go ahead and try graphing this one on your own. In this case, our vertex is at -2, -4. Our next points are -3, -3, and -4, 0. That axis of symmetry is that red dashed line at x equals -2, and you can see the points getting mirrored across that line. The next thing we're going to do is write a function when we have a graph given to us. So in this case, it's telling us that the graph is a translation of x squared. That means there's not going to be an a value. We don't have to go through and figure it out. So when it's simply telling us it's a translation, our key here is to pick out the vertex. So I'm going to go ahead and look at my graph, and I notice that my vertex is at 3, 4. So I'm going to make note of that. My vertex is at +3, +4. So I'm going to go ahead and plug it into my equation then, and I'm going to say f of x is equal to, we don't have an a value because it's just a translation, so I'm going to say x minus 3 squared, plugging that h value into its correct spot, and then plus 4, plugging that k value into its spot. Go ahead and find the equation for this translation on your own. Pulling out, your vertex is at -6, -2. Plugging into the equation, you end up with x plus 6 in parentheses squared minus 2. Now, when it doesn't tell you it's a translation, it's going to give you an additional piece of information. So it's going to give you 2 coordinates to work with. The first thing you need to do is use, that vertex coordinate. So you're going to plug that in, and you're going to say f of x is equal to, now we're going to include an a value, and then we're going to say x minus our vertex point, so that h value is -2, giving us a +2 squared, and then minus 7. So that's the initial equation that we have. Now, in order to figure out the a value, we are going to plug in -3 as x and -9 as f of x. So I'm going to say -9 equals a times -3 plus 2 squared minus 7. Solve this part in parentheses. So -3 plus 2 is -1. Squared is 1. So I've got 9 is equal to 1a minus 7. Now because it's a 1, I don't need that value here. If it was a 2, a 3, a 1/2, whatever it is, if it's something other than 1, you're going to want to include that coefficient in front of your variable. In this case, because it's 1, I don't need it. I'm going to go ahead and finish solving this by adding 7 to both sides, and I'm going to end up with a value of -2 for a. So my final equation then becomes f of x equals -2, that a value we just figured out, and then x plus 2 in parentheses squared minus 7. So that is the full equation for this graph shown at the left. Go ahead and try this one on your own. Pulling out that vertex, you're going to plug in a 4 and a +5. When you plug in for x and f of x, you're going to use the 3 and the 5.5. Again, that inside the parentheses is going to turn into a 1, so we can drop that coefficient as we solve, and we end up with the final equation, 0.5 parentheses x minus 4 squared plus 5. Last thing we're going to do is talk about applying quadratic functions. So, for example, Tori is standing at home plate at Fenway Park. He hits the ball and it follows the path f of x is equal to -0.0014 parentheses x minus 200 squared plus 60. The ball must go over the green monster, which is 310 feet from home plate and 37 feet tall in order to be counted as a home run. assuming that home plate represents x equals 0, will the ball be a home run? So our job here, in this case, they give us the equation to work with. So we don't have to write the equation, we can just start plugging stuff in. We want the ball to be 310 feet away from home plate. That's the distance it needs to go in order to be considered a home run. That is what is going to get plugged in for x. So what you would do here is say f of x is equal to negative 0.0014 times 310 minus 200 squared plus 60. When I do that, 310 minus 200 is going to give us 110. When you square that, you're going to get, so 110 squared is going to give us a value of 12,100. So I've got negative 0.0014 times 12,100 plus 60. After I do my multiplication there and do negative 0.0014 times 12,100, I'm going to get f of x is equal to negative 16.94 plus 60. When I do my addition then, I'm going to end up with a value of f of x is equal to 43.06 feet. So that means at 310 feet, the ball is 43.06 feet in the air. So now to answer the question, will the ball be a home run? If the green monster is 37 feet tall and the ball is currently at a height of 43 feet, then your final answer would be yes, it is a home run. And you could potentially need to give an explanation, which if you needed to do that, you would say yes, it's a home run because it is taller, or it is higher than the fence height. It is taller than the green monster. One more applied problem that we're going to work through. I'm going to start it. You're going to finish it. We have Deshaun and Kelly are playing soccer. Kelly takes a shot on goal. Deshaun is 3 feet in front of the goal and has a vertical reach of 8 feet when standing. We are wondering if he can block his shot in this current position without jumping or moving. Now notice, this one doesn't give us the equation to work with, but that's fine. We know how to find an equation. It doesn't tell us it's a translation, so we are going to have to account for that a value. So I'm going to start by saying f of x is equal to a parentheses x minus our x coordinate, which is 16 squared plus 11. So that's going to be my initial equation that I'm going to start with. Now the other point that it gives us is this 2 and 1.2. So I'm going to plug those values into the appropriate spot. So I'm going to say 1.2 is equal to a times 2 minus 16 squared plus 11. When I do 2 minus 16, I'm going to end up at negative 14. Negative 14 squared is 196. So I'm at 1.2 equals 196a plus 11. In order to get rid of that 11, I'm going to subtract it from both sides. When I subtract 11 from 1.2, I get an answer of negative 9.8 is equal to 196a. Then I'm going to go ahead and finish solving for a by dividing by 196 on both sides. And once I do that, I get an a value of negative 0.05, meaning my equation is f of x equals negative 0.05 parentheses x minus 16 parentheses squared plus 11. From here, I want you to, knowing that Deshaun is 3 feet in front of the goal, I want you to figure out whether he can block Kelly's shot or not. So in order to figure out if he can block the shot, the next thing we're going to have to do is figure out where he is at. If the goal is at 25 and he is 3 feet in front of that, that means our X position here is going to be at 22. So I'm going to say f of x is equal to negative 0.05 times 22 minus 16 squared plus 11. 22 minus 16 is going to give us 36, is going to give us 6. And then when we square that, we're going to end up with 36. So I'm at f of x is equal to negative 0.05 times 36 plus 11. When I do 36 times negative 0.05, I end up with an answer of f of x is equal to negative 1.8 plus 11. And when I add 11 to that, I get a final answer then of f of x is equal to 9.2 feet. Since Deshaun's reach is only 8 feet into the air, our answer for this one would be no. He won't block the shot. Because it is too high. So again, we can use these quadratic functions to help us solve the problems. If you have questions about this or anything else from the lesson, please let me know when you get to class.